Hi, I'm Dr. Gil Welch. In this short take, I want to talk more about interpreting 95% confidence intervals. I want to talk about their relationship to p-values, and I particularly want to talk about how useful 95% confidence intervals can be in interpreting a so-called negative study. You ready? The last video, I went over the simple things you should know about 95% CIs. First, that in all studies, the observed effect size is only an estimate of the truth. Second, the 95% confidence interval is the range of values around the effect size that will contain this truth 95% of the time. And third, a narrow confidence interval means we're pretty sure where the truth is. A wide confidence interval means we are not. Now for a couple of advanced points. How do 95% CIs relate to p-values? Well, if the p-value is greater than 5%, then the 95% CI should include no difference between groups. So here's a confidence interval. Here's no difference between two groups. This confidence interval crosses no difference, so the p-value is greater than 5%. Same's true for this confidence interval. The main effect may be on the other side, but the confidence interval still includes no difference between groups. If the p-value is less than 5%, then the 95% CI should not include no difference between groups. It should be either over here or it should be over here, but it does not cross no difference between groups. Now, I said this on the last video. Let's see if you're ready to guess the p-value. Here are 4 studies, and all you've got to do is check whether the p-value is less than 0.05 or greater than or equal to 0.05. I'll even put that slide in so you can review it. Stop the video here and make sure you can put a check in the right box. Okay, I'm going to tell you the answers now. That is less than 0.05. The second study is greater than or equal to 0.05. The third study is greater than 0.05. The fourth study is less than 0.05. If you really took the time to do this, you now recognize an issue. The value of no difference differs. Wow, that's complicated. When the effect size is measured as subtraction, say subtracting the mean of one group from the mean of another group, no difference is 0. So that means the no difference line is 0, and on one side is negative, the other side is positive. For example, 15 versus 8%, 95% CI for the 7% absolute difference, 2 to 12%, those are all positive numbers. Never crosses 0, that is statistically significant. On the other hand, rows 2 points, 95% CI minus 1 to plus 5 points, that includes 0, that crosses the no difference line, that is not statistically significant. The p-value is greater than 0.05. On the other hand, when the effect size is measured as a ratio, no difference is 1. That means the numerator and the denominator are exactly the same size. So, now no difference is 1, and the one side of the no difference line is less than 1, the other side is greater than 1. So a relative risk, that's a ratio measure, equals 1.4, 95% CI, 0.8 to 2.4, that crosses 1, that's not statistically significant. Here's another ratio, an odds ratio of 0.6, 95% CI, 0.4 to 0.8. That does not cross 1, doesn't include 1, it's over here, it is statistically significant, p less than 5%. So here's the advanced point. The 95% confidence interval does contain information about the p-value. If it includes no difference, then p is greater than 0.05. If it does not include no difference, then p is less than 0.05. Your challenge is to figure out what the value of no difference is. If it's a subtraction, no difference is 0. If the effect size is measured as a ratio, no difference is 1. So here's a confidence interval. It's pretty tight and it doesn't come anywhere close to no difference. It actually tells you something about the p-value. It's going to be very small. In this case, less than 0.001. But as the confidence interval gets closer to touching no difference, the p-value will rise. Here, p equals 0.01. Now it's almost touching no difference. That means p equals 0.4. Excuse me, 0.04. It's almost touching. And if it touches exactly, the p equals 0.05. That's a fun thing to know. Tell your friends about that. If it goes across, now you know it's above 5%, p equals 0.06. Goes way across, p equals 0.1. Way across, p equals 0.25. So the 95% confidence interval, in fact, communicates something about the magnitude of the p-value. Now let's move to negative studies. For example, the efficacy of new drug in preventing heart failure was not significantly different than that of old drug. This is a so-called negative study. The p-value is greater than 0.05. But does it look like this? Because then we're pretty sure there's no difference between new drug and old drug. But as it gets wider, we're less sure, and wider, we're even less sure, and less sure, until, if it's wide enough, we're totally unsure what the truth is. It's possible that new drug is much worse than old drug. It's also possible that new drug might be much better. We just don't know. And so you have to look at the confidence interval and make your own decision about how precise it is in knowing that there is in fact no difference. Are all negative studies, p greater than 0.05, equal? Well, here are 4 studies around a relative risk, so no difference equals 1. I'd argue these are very, very different studies. The first 2 are tight confidence intervals, so we're certain that the effect is small either way. We're comfortable saying there's no difference here. But here, this is a wide confidence interval. We're not very sure about where the truth is, but it sure looks like there's something that might be worth exploring. Most of the confidence interval shows benefit. While here, the situation is grim. We're not very sure, but most of what we know suggests this drug probably ought to come off the market. So that's the final advanced point. A confidence interval is particularly useful in assessing a negative study. If the confidence interval is wide, then the study may be missing an important effect of either benefit or harm. One final caution. A conclusion based on a study with an extremely low p-value, that is highly significant, and an extremely tight 95% confidence interval, that is very precise, can nonetheless be extremely wrong. In all studies, the focus may be on the wrong patients or the wrong outcome. And in observational studies, the relationship may be confounded by a third variable. That's why you should care about the study design. Statistics are arguably the least important topic for you to worry about. Hope this helps.